It
Okay.
hasn't started yet.
Yeah.
Wait, okay. Yeah.
Okay. I think it's recording now. So, Chandan, this side, I joined PIO like 2 weeks back, and I've been working in IBMi for past 2.5 years. And today's session will be conducted by Mitesh on error handling in CL programs. So, Mitesh, I'm handing over the session to you. So, you can go ahead.
Yeah, thanks, Chandan. Good afternoon, everyone. This is Mitesh Shantakumar. I have been working in IBMi for about 4 years, and I have been associated with programmers for about a year. Today, we'll learn furthermore concepts about CL programming. So, I'll just quickly share my screen. Please let me know once it is available.
Yeah, Mitesh, we can see your screen.
Okay, thanks. For as of now, we know what is a CL program and why is a CL program used. What is the basic structure of CL program? Today, we will learn about a few more concepts on CL. That is, how do we handle error in a CL program? How do we declare and read a file in CL program? And we'll learn about the commands OVR, DBF, and Open Query file. So let us quickly jump to our first topic, that is error handling in CL program. So we all know that how crucial is error handling or exception handling in a programming is. So in CL program, we handle error using a command known as monitor message, that is mon message. So what actually happens is that whenever a command ends in an error, or the command fails, a error message is sent to the place from where the command was run. If the command was run from a program, then an error message is sent to the program queue of that program where the command was run, and each of the message has a particular unique message id. So what this command does is, this command captures those message ids and takes the necessary action whichever we mention there. So we have two types of monitor message, that is a program level and command level. Let us quickly jump to the session to learn more about it. So first we'll see that this is I have created a simple CL program where I am checking whether this object, that is EMP mask of type file, is present in qtemp or not. So what I'll do is I will just quickly call this program. So as we see, the program fails and it has ended an error, and it shows that CPF 9801 is received by the procedure mon message CL. This means that the program has ended in an error, and an error message with ID CPF 9801 is sent to the program queue. So how do we handle this? And we can see here this has resulted in an error and the program is ended abruptly. So we handle this using the mon message command here. So let's see what are the parameters of this mon message command. I do a prompt on man message. So as I said that this basically identifies and handles the error messages using their unique message ID. So this first parameter is where we give the message IDs which we want to handle. So we can give either a single, or we can add about 50 error messages at a time. And the structure of message id is like this. The first, it is of 7 characters, and the first 3 characters are always alphabets, which either define whether it was an error in command processing or it was any other OS level errors. So as we see here, it was since we are handling the error on a command, it starts from CPF, and there are many other types of message IDs like MCH and all. And the last 4 digits are always numeric, which uniquely identifies the message. The second parameter is an additional option parameter, comparison data. As I always said, that an error message is sent to the program queue of that program. So here we can additionally mention a characters up to 28 characters, which would match with the message that is sent to the program ID. And this next parameter are the steps what we want to do in case the error occurs. So as we can see here that I have captured this error CPF 9801, and I have done command to execute as do. So it would do the below steps. So whenever an error occurs of message ID CPF 9801, then it would do this below steps. It will send a message to the user that object is not found, and it would go to the end of the program. And that is here. The label is here. So I'll just quickly compile this and take this in debug, and let's check what happens here. So I debug this program and call. So let's see here. It there occurred an error with message ID CPF 981. So it came here. It sent an error message and went to the end of the program. So here we have successfully handled this error. Now we can see that since we have mentioned this mon message just after this command. So this mon message will only act or only capture the error messages that has occurred in this command. Hence the name command level. So this mon message becomes a command level mon message. And how do we identify what all error messages can occur in a command is that we can prompt on the command which we want to run. We can go to the help section, and in that help we can go at the bottom. So here we can see that it all the error messages that this particular command might throw are mentioned here. So either we can select it from here, or we can also Google for the error message, or we can run the command and check what all error message has been found in this command. So I guess we now understand what is a command level mon message. Now what I'll do, we'll go to the next type, that is program level mon message. So I'll just quickly comment this command level and uncomment this program level. So since this is a program level mon message, it means that it will handle any of the error that occurs throughout the program. So we are placing this mon message immediately after all the declaration part. So this would be the first command that in our program, first command of the major operations of our program, so that it would handle all the error which occurs throughout a program. So I have mentioned here CPF 0000. Now what is this CPF 0000? Like we saw that here it was a specific message ID CPF 9801. So, what if I am not aware that what message IDs would come? So, in that, I would mention a generic message ID, that is CPF 0000. What this command will do, that it will handle all the message error IDs that starts from CPF 0000 and goes till CPF 9999, since 9999 is the maximum four-digit number. So it would handle all the message IDs between those. Fine. So what I'm doing here is that whenever any error message starting from CPF occurs, it will directly go to the error line. So I'll again compile this and let's check in debug what happens here. I am I'll first end debug and then start the debug and call this program. Now I run this command. This command fails and the control goes here. Now what happened was that this had sent the message ID CPF 9801, which was captured by this mon message, and it as I had mentioned here, go to command level error. The control goes here. So this program level mon message can be used to capture any generic any generic error that occurs in the program, and we can give any generic message such as error occurred in the program. So we have got the message error occurred in the program and the program ends. So I hope we understand now what is program level and what is command level. The command level mon message occurs just after a command, and it will capture all the errors that occurs in the particular command. Program level mon message captures all the errors that occurs throughout the program. Now always now if I uncomment this one and if I keep both command level and program level, then always command level takes a precedence over the program level because it is just after the command, right? So in this case, now this particular step will be executed and it would not go to the error command. Fine. So so now we know what is monitor message, and we have saw the types of monitor message, and we also saw the generic monitor message. So like now if I change if I only want to handle all the error message starting from 98, so I can give here 9800. So what it will do is it will capture all the error message starting from CPF 9800 to till CPF 9899. So this is a form of generic message. Now there is an another generic message that is CPF 9999. 9999. So as we saw that CPF 0000 would handle all the error messages starting from CPF 0000. So CPF 9999 will handle all the error messages that begins with 9999 and goes beyond. So after CPF 9999 would be some other message ID starting from some other alphabets, let's say MCH or any other OS level error. So if we'll just quickly demonstrate that. So what, like we saw when I had yes 0000, the command directly control directly went here because this was handled by this mon message. Now what I will do is I will change this to 9999 and let's check what happens here. I'll get this in debug and call. Now it goes here. Now as you can see that the error message has been sent to the program queue. This was not handled by our mon message CPF 9999 since the error message CPF 9801 is less than 9999. Okay. Now I do. Now the control goes here as it was mentioned here, go to err. Why this happens? Now this happens because the command has failed and this has led to the abnormal completion of the program. So this itself has turned into some other OS error. That is the reason, and it had sent that error message with a message ID which is greater than CPF 9999. So that was handled by this monitor message. Now this goes to the command and it gives error in the program. So if I will check my DSP job log, I'll do F10 and F6. So you can see that the program was ended in error because this object was not found. But it didn't lead to abnormal termination of the program because we had CPF 9999 here. I hope this is somewhat clear, the difference between CPF 0000 and CPF 9999. Now we'll move to the next part, that is declaration of a file in CL program. Like we have already studied, in order to declare a variable, we use DCL command in CL program, and in order to declare a file, we use declare file command, that is DCLF. So if I'll go here and let's check what are the parameters of the DCLF. So in this simple program, I have declared a variable and I have declared a file. So if I do prompt here, the first parameter of this command is the file name which we want to declare with its library, and the next parameter is the record format. So we all know that in CL program we can only either declare a database file or a display device file. So database file, if it is a PF, then it would only have one record format, and if it is a logical file, then it might contain more than one record format. And if it is a database display device file, that is display file, then it might contain more than one record. So here we can mention which all record formats we want to include. Either we can give a name, or we can use the star all, which is by default. This would include all the record formats. This is a open file identifier. This is an identifier which we have to use in case we are using multiple files. In case we are declaring more than one file in a CL program, this acts as an identifier for each of the file. The next is, since now we are defining only one file, we need not provide this. We can, but there is no need. The next is allow variable length fields. So these four parameters are for the files that depending upon their properties of the field. If the file which we are declaring has a field with variable length, then we have to provide yes, either star yes or no. If there is an allow null keyword associated with a field, then here it would we would mention is as it is. And if the field is of a graphic data type, then here we have to mention yes. And the next is, if the field is of binary type, that is if its data type is b, then we must mention that whether that binary type should be considered as a decimal or a integer. So why this is required? Because whenever I declare a file and in a CL program and compile the CL program itself generates a CL variable for each of the fields present in the file with the same name. So in order to create those, we need to mention these also, like how the CL variable should be created. Okay, so these are the parameters for DCLF. Now I have declared a file. Now I want to read those, but that the file which I have declared. So in order to read the file, we use RCBF command, that is receive file. So what does this receive file is just okay. First of all, this receive file command cannot exist without a DCLF command. There must be a DCLF command for every RCBF command. So what this RCBF is does that it would read the file which we had declared above previously, line by sequentially, line by line from top to the bottom. So the first parameter is display device. In case we are declaring a display file which is displayed on multiple devices, so there we can here we can mention whether we want to only read from a particular device or not. If not, then we can simply mention star file. So for database file, it is star file. Record format, the RCVF can only read from one record format at a time. Like in DCLF, we can mention multiple record format, but while reading, it can only read from one record format. So if we want to read from any particular record format, we can mention it here, or we can leave it as star file. Open identifier is the identifier which we had mentioned in the DCLF command. And wait. So what this wait is that this wait defines whether the commands just after this RCVF command should be executed even if there is no data received by this RCVF command. So let's see, for example, if we have a display file and we are displaying a screen and there is an input field on the screen. So if we mention a star yes, then this RCVF command will wait till the user enters the data into the field. And if we mentioned it here as star no, then it would immediately execute all the commands after this RCVF command, even if the user doesn't enter the data. That is, it would not wait for the data to be entered. So that is the purpose of this wait command. Now since we are declaring only one file, I am not mentioning any of the parameters here, and let that all be used as default parameters. So next is mon message cpf 0864. Now as we saw, mon message is used to handle the error. Now this command rcvf command ends in an error if it tries to read beyond end of file. So that end of file condition is identified by this message ID CPF0864, and if the end of file is reached, then we would simply go to the end of the program. In next line, I am just reading this file. Like we can see here, this okay. Let's see first what is the data in our employee master file. So we can see it has ID, fields as ID, name, department, and process, and the field names are here: EMP ID, EMP name, department, and address. So you can see that it has already created a variable with since the variables in CL starts with ampersand, so you can see that it has created a variable of the field name. Okay, now since the ID is a numeric, I had just converted into character and displayed in the message. So let's quickly run this program and see. So it has read the first record, that is 001, and if I press enter, it has recorded the 002, and if I enter, it has read the third record, and then end of file was reached and it went to the NTGM. Okay, so this was simply reading a single, declaring a single file and reading that. Now, next we'll see how do we declare multiple files. So, CL has a restriction. We can only define a single file without, if we are not using any OpenID, we can only define one file in a CL, and with OpenID, we can define maximum of 5 files in the CL program. So like I see here, I have two files, emp must and cust must, and I have given the open id as f01 and f02. So when I do rcvf with the open id f01, it would read the first file, and we can see that whenever I use open id, the CL program creates the CL variable with the name of the field, prefixing that with the open id, so that there is no conflict between the files. If the files contain same name, fields contain same name, then that would be differentiated using the open id. So like see here, I am first reading the f01 file, displaying the data from that, and once the end of file is reached for the first file, then I have executed go to label 2, and then it would read using the OpenID F02 and then display the detail from that. And then if the end of file reaches for the second file, then it goes to the end of the program. Let's run this program and see. So here you can see that it is displaying the data from our first file. So first file, then press enter, and goes to third record. And now since it has only three records, the end of file is reached for the first file. Now on pressing enter, it would read the next file, that is our customer master file. So if we check this data, so the it has three records here. So it is displaying the first record from here, second record from customer master, third record from here. And then after it reached the after the third record displayed, it went to the end of file. So this was how do we declare and read multiple files in a CL program. So let us see how do we declare a display file and use those in a CL program. sorry. So here I have declared my display file, that is screen1 in the library, and I have mentioned two record formats, screen1 and screen2. This sndf send file command is used to send the display file to the screen, such that because in display file we first write our file to the screen and then read from there the input data. So this command would write that file to that device, and we would learn about this in detail in upcoming session. And here I am reading that particular record format and displaying the data entered in that screen. So I am displaying the screen to record format and reading the screen to record format and displaying the data entered in the screen. So what happens now? So if we notice here, I have mentioned yes star wait as star yes. So we'll call this program. So this is the screen which is been written onto the screen. If I mention department as IT, so here it has read that particular field and displayed what values was written here. So what it does was it waited till I enter the value. Now what happens if I change this value to star no? So I will change the value to star no, compile this and call. So what happens? Let's check what happens if I call this program. So as we saw, it didn't wait for me to enter the data and it executed the next commands immediately after that. So since there was no data, it is displaying empty. So like it didn't wait for the user to enter the data and executed this command directly. So this is the purpose of wait command, wait parameter of this RCVF command. So I hope this is clear. So we have read how we have understood how do we declare a file, what is the purpose of OpenID, and how do we read a file in CL program. So now let us jump to the next. Overriding a file in CL program. So let us first understand why do we need this. So now as we saw we have an master file, EMP master file. Now this EMP master file is a multi-member physical file. So how do we check get all the members of a file is using DSPFD command. If I do EMP mask the library and in the type of information I enter member list. So this says that I have this um, these many members in this file. So one would be the same name as the physical file. One member is named as HR, one member is IT, and another number as sales. So if I want to check the data from these members in run query, we have a parameter there. Like here, if I mention EMP mast, here I can mention the member name. So if I mention the member name as IT, then I would be able to see the data of that member. But by default, whenever I do run query on this file, it will by default give the name of first member. Like it would give the data of the first member. So what if I want to read the data from the member other than first in our CL program? So that is one of the case where we need to use the OVR DBF command, that is overriding a database file. So there are multiple uses of this command. One of the uses this command. Sorry. So let us quickly see what are the parameters of this OVR DBF command. Sorry. So this is the first. Uh, this is the from file or the base file. Like overriding itself means that overlaying something on upon something. So what we are doing here is we are overlaying some another file or some other properties of that file upon our base file. So this is the file which we would be overriding, that is the base file. This would be the new file whose characteristic would be overlaying our base file. This, that is the to file. Here would be the new file name and library. The any member, we particular member if we want, we can mention here. And another scenario where ovrdbf command can be used is that we want to, if we want to read the data from any, like set a pointer at a certain location, yeah, certain record in a file and read from that file, in that case also we can use ovrdbf command, because we saw that in rcvf command it would read sequentially. There is no other like way in positioning in the rcvf command. So we position the cursor on the file using this ovrdbf command. So how do we do this? Either we can, first of all, we mention here where do we position our pointer. Either if star none, then it would read by default from top to bottom. If star start, it would position the pointer at the beginning of the file. And if star end is used, then it would place the pointer at the end of the file. And the subsequent read would fail because it would give the end of the file. Other which values which can use is star rrn. So rrn stands for relative record number. So every time we know that every time we write a record into a file, there is an rrn number associated with it. So if our file doesn't have any key and we want to read from any particular record only, so here we can mention star rrn. And if our file has keys, so we can use any of these parameters if we want to position on the value of that key field. So key B stands for key before, key BE stands for key before equals, and key stands, this is the value for key, and key after equals, and key after. Okay, so then if we, based on the parameter that we mention here, the next parameter would be based on that. If we mention here RRN, then here we would provide the RRN number from which we want to read that file. If we are mentioning star key here, then we would mention how many number of key fields we want to use, and either it can be 1 2 3 or any number. And this number does has is not mandatory that it should match the number of key fields in the physical file. Let's say if our physical file has three key fields, and if I want to only position based on one key field, then I can mention here one. Okay, so the next is record format, which record format name which we want to use. And the next is a key value. If we are using positioning based on the key field, then here we would give the exact value where we want to position our cursor or pointer, and then read. And if we see, then it has many other parameters like the record format log. It would, we can mention here the type of log that would be imposed when a particular record is read. And you can see here these are all the parameters which were used while compiling a physical file. So other use case where we can use this override dbf command is that we want to override certain parameter or properties of a physical file for a temporary purpose, temporary amount of time. So there also we can use that ovr dbf command. One of the important is parameter is this secure from other overrides. So now the override occurs at various level. There can override can occur either in program level, it can occur either in command line, that is command line in a pdm or main command line. So what this parameter does is that if we mention here star yes, so no matter how many overrides has been done on that particular file, are this override would be executed no matter how many other overrides were already done on this file. We'll see the example which would make it much more clear. The next important is the override scope. So whichever we are overriding, what would be the scope of that override? So it can be either till activation group or the call level, or it can go until till entire job level. The share open data path parameter. The open data path is the path through which the all the IO operations on a file is performed. So whenever a program opens a file, every time the program opens a file, a new path is opened. So now if we want to share this path with any subsequent program, we can provide yes as star yes. By default it is star no. The open scope. Now open scope is the scope of the file which we have opened. So it can be either till activation group only, or it can go up to the star job. Okay, so this was all the parameters of the OVRDBF command. So let's check an example. So what I am doing here is that I have declared the file emp masked file, and I am overriding this emp masked file with itself, but I am overriding the member IT. So like we saw here, the EMP mask file has multiple member, and I want to read from a particular member other than the first member. So I am doing overriding it with the member, and same we are reading this file and displaying. Let's see what happens if I run this program. So if I run this program, like we saw, it is reading from the department IT and not the department prod which was present in the first member. Okay, so we saw it has overridden that, and this command delete ovr command is used to delete the previous overrides which we have done. I hope this is clear. So this was a simple scenario where we had used the OVRDBF to override a member. Let's see another scenario where I want to position a particular like I want to read based on a particular value of the key. So if I check here, I have declared a file pf001, and in this pf001 I am positioning is based on the key field, that is key field number 1. This is the record format, and this is the value which I want to position. So if we check the values in the file pf001, so you can check there is ID and name, and it has these all values. So what I am doing is this, on the based on position key, I am positioning it on 03 and then reading from that. I have set the pointer here and then I am reading. So I'll just call this program and check. So as we see, it has skipped these two records and it is reading from the third record since we had set the position here. So it reading ID 03, 04, 05, and it comes to the end of file. Now let's quickly check the difference between this after and after equals. So what this key is that tells is that it should look for the exact match which we have mentioned here. Okay, now let's see. Here we do not have any ID called as 00. Let's see what happens if I enter 00 here and then I compile this program and call. So this sends me an error message and this fails because it tried to find the exact match of that value and it couldn't find. So the positioning failed. Hence the program ended in error. So this is the drawback, or we can say the purpose of star key. Now let's see if I enter here star key a, that is star key after. So after equals, what will it do is that it would check for the exact value. If not found, then it would set the pointer at the next greater value of the id of the key. So I have used the key after and I have positioned it to 00. Now let's see what happens. And so it has it looked for 00, it didn't found 00, so it's set the pointer at the next higher location, that is 01, and then it would read till the end of file. Okay. Now what key, this was key after equals. Now what if I use only key after and I set any particular value that is found? So what it will do is it will set the pointer after that. So let's see, like you see, I had set it to 00 after. So it set the pointer here, and then from this, it will read on. So this is, and the key before functionality is similar to this. So key before would set before the value which we have provided, and key before equal would set, if not found, then it would set any next smaller value which we have provided, and key would look for exact value. Um, I hope this is also clear. And this OVRDBF command we can use in any number of ways. You can always go and explore this command, and if you get stuck anywhere, you can always come back to us. So, okay, now next is, let's see what is DSP OVR command. So I what I'll do is I will just quickly debug this program. So now the OVR DBF is done. What if I need to check what all overrides are happening in a particular job? So for that we use DSP OVR. So what this does is it will display all the overrides that has been occurred. Let's see display override. So here we can either mention a particular file which we want, or we can mention star all, which would show all the overrides that is occurring, or we can mention star pf, where it would only provide the override that is occurred on the printer files. Merge overrides is star yes. What it does is that if there are multiple overrides in a single file, then it would merge all this file and show, and these are the levels of the override. This is the output. How do we want? Either we want the print or we want to display. So if I press enter, sorry, we can see that there is one override on file emp mast. The type is db, because since it was a physical file, database file. And what was the override? This was the override, the new file. That is the same file with another member. If I take here option 8, then here we can see that level. This is the level 10. So as I said, override occurs at various levels. So since we are doing this override within the program, the number assigned to it is level 10. Higher the number, lesser would be the priority of that override. So this is the purpose of the DSP OVR command. So now let us do one more thing. Let us override from here. Now this is the command line. I am doing override the command line inside the PDM. Okay, so I'll just override the emp mast file with some other member. Let's say sales. I press enter here, and if I do DSP OVR, then I can see that there is one override and its level is 7. So which is less than the earlier override that we had done in the inside the program. Okay, now if I do take this program in debug and do another override, and if I again do DSP over here, then since we had used the merge star yes, it is showing only one record. But if I take option 8, it shows that there was two overrides done. One with a sales member that was done at the command level and command line level, and another was inside the program level. Okay, now let's see what data is being displayed. If I do F10 here, we can see that sales members data has been displayed here, because the level of that override was 7, which was less. So lesser the level, greater would be the priority. So if I go, it will read all the data from sales member only. And this goes to delete OVR and goes to npm. Now if I do DSP OVR, let's check what override did the delete OVR did. So delete OVR only deleted the override which was immediately preceding that particular override. So we can see that the override done at level 10 was is gone now. Okay. So if we want to delete this particular override, then we will do override here. There are no overrides. So higher the number in the level, lesser would be the priority. I hope we are clear with this. So we have seen how do we override a database file. What is this DSP command? What are the level? There are now for now we saw only two levels, that was 7 and 10, where 7 was the command line within the PDM. If we can also do the override at the main menu, that would be level 2, and it would be having the extreme precedence preference. Then delete OVR command is used to delete the override which we have done. And the next is since this was OVR DBF, that is override database file, we can also override a printer file in CL using OVR PRTF command. So this command is used to override any printer file. So basically this is used to override the certain parameters of the already existing printer file. So we can check here that we can always change the values of these, like we can change the printer device where it is been sent. We can change the page size, length and all. So this is basically used to change the certain properties of a printer file. So this has all these parameters are available while creating a printer file when we do a CRT PRTF command. So here also there is these important parameters which we saw in OVR DBF command, that is override scope, share ODP and open scope. So basically, this OVR PITF overrides a printer file. We can, if we do DSP OVR, then it would display all the overrides. That is either in database file or a printer file. And in order to delete the override in printer file, we use the same command, that is DLT OVR. Okay. So let's move to next. Now this overriding of a member can be done in RPG program also using the keyword that is extmbr. This extmbr is a keyword which we can use in the file specification. If we can quickly go through an example here. So like we see, I have mentioned declared a file emp must, and I have mentioned a keyword extmbr, that is external member. Here we can specify the name of the member which we want to open if we want to open the member apart from the first member. So either we can mention here star all, which would override all the members, and we can read all the members, records from all the members from top till the end of the file, or we can mention star first, which is the default behavior, or we can mention the name of the member which we want in quotes, or what we can do is we can mention here a variable name. Sorry. So why do we use a variable name here? That there may be scenarios where we want to dynamically open any particular member of a file, so this allows us to do that. So like we see, I have used here a variable name, and I have initialized this variable with the member name, and I am also using a user open keyword here. So basically user open keyword, as we all know it, allows the user to explicitly open and close a file. It is better to use user open if you are using a variable name here, because we every time we need to open a file with a new member. So for that I have used user open here. So in the main line I am first checking whether if my file is open, close the file. I'm explicitly opening the file and just reading the data from that file. So what happens if I run this program? So I'll call this program and we can see that it is displaying the data from the sales member, that is hence the department sales. This is a one way which we can override a member in RPG program using the external member keyword. Let's go to the next topic, that is open query file. Okay, so the open query file is you this command is used if in case we want to fetch a set of data from a physical file from a physical file based on certain conditions. So this open query file will create a temporary access path, that this temporary access path would be closed or would vanish once we close the file. And so now why do we need this? So we all know that in logical file we can select a particular set of records or omit a particular set of records using select or omit, but that would be permanent object, and it would remain till the object remains there. We what if we want to read the file and capture a set of records based on changing conditions, and we do not want a permanent object of that? So in that case we use open query file. And so let us see the parameters of open query file. So here, this is the command open query file. So here this would be the file from which we want to retrieve a set of records. We can either mention one single file or we can mention multiple files, where mentioning multiple file would denote that we are joining multiple files. This is the open option. This denotes what for what purpose we are fetching this record. Either we are for fetching only to read the record, or we want to write a record or to update or a delete records. So we can either mention any of this modes in which we are opening, or we can mention star all. This is the record format name which we want, which is used for the file that is open using open query file. This is query select expression. This is the condition on which the record would be fetched. So here we can mention any conditions. All the logical operations or any calculation by which we want to fetch a record can be mentioned here. And this is the key field. So another, like we saw, open query is used to fetch a record. Another use of this open query file is that we can dynamically mention any key fields here. If our file does not have any key, so we can dynamically create any key field. Here the file already has a key id, so I am mentioning is that key field as id here. And then I can also mention in which order to be read. So for by default it is read in ascending order. I have mentioned here descending. So this will check are there any should there be any unique key fields. So if the next parameter is join field, if we are using more than one files, then we need to join those files based on certain conditions. So that condition would be here, like there should be some matching fields into it. So here would mention the field from first file which should match the field from second file. So this is the from field, this is the to field, and this is the default value. Like before that we have the join operator. So this tells the condition, like the join should occur with, on which condition should it fetch the equal values or not equal values, greater than, or so on. The next is a join with default values. So what this does is that if from file from if the record from the first file does not find any matching record, so in that case what it should do, so should it default the values or should it not? And this only default only default would result in all the exception records, which the records which are not matching on the both the file, only in that. So we can also group the records based on certain field name by mentioning the field name here. And then this is the condition on which the grouping should occur, that is group selection expression. And this is the map field. This map field is used if we want to rename our field, or if we want to define our field in some another way. Let's say suppose if we want a field where it like where it gives the total cost of an order, so in that case we would be requiring the cost as quantity into the cost of one quantity. So that we can mention here, like we can mention the name of the field, and here we can mention the expression like one quantity into cost per quantity. So that would be the in that case this field would be created. So here we can mention whether this map field is of what type, is if it is calculated or it is binary type, its length and all. And here we can mention that whether the open query, the file which is open, it should ignore the decimal data errors. And here you can see that what should be the scope of the file which we have open. Either it can be the activation group, or it can be the job level, or we can allow we can allow the copying of data, which for which the allow copying of the data uh, which we have open using the open query file. And then these are the parameters of open query file. So open query file. So there are few steps for using the open query file. So first we need to um, override, because we are opening the query file and we are fetching only a particular record from the query file. So we need to override this database file, and we need to share the open data path, because the subsequent commands or the programs which are called after this open query file should fetch the records from this open data path only. As I said that every time the file program opens a file, a new data path is open. So if we want to share, we do not want that, and we want to share the data paths, since that it would have only these particular records. So here we have star yes, then we do open query file, then we do the processing, whatever, either we would be displaying it in the same program, or we would be calling some another program. Then we would, after the processing is done, we would close the file, which since this is very important, because we are opening that file for a temporary purpose. So if we do not, if we'll not close this file and again we'll try to open, then it would this open query file would end in an error. So after the processing, we must always close this file which we had opened, and this closed file has an open id. This is the name of our file, pf01. This would clear, or this would end the access path which we had open using open query file, and then we would delete the override which we have done here. Okay, so so let us see what this star okay, so I'll just compile this, run this row. So we can see that since we had mentioned the key in descending order, it is reading from the descending order, that is 05, then 04, then 03, and the program ends. Since I had mentioned here only the records which is greater than 03, and I had mentioned here key field as ID, and in descending order it only selected those particular records. Okay, now let us see what happens if I if I do not share the OTP. So I have used star no and calling this. So we can see that it is reading from the beginning of the file, even though I had opened the query file, because the DCLF has opened a new data path and we are not sharing the data path. So it would read from the beginning and go till the end of the file. Hence, it is always important to use to share the ODP whenever you use the open query file. Okay, so this was the scenario where we are selecting a particular record from based on the query select. Let us see another scenario where we are joining the two files and selecting two particular record from these two files. So what I am doing here is that I am um, using two files, that is emp master file and salary master file, and we are using this only to read. So the mode in which we open is star imp. The format which we using would be of the primary file, that is emp master file. The condition on which we would be joining would be the fields of id. So they we would condition, and since I have not mentioned here any join operator, so by default it would be star equal. So this is the join condition. It would be joining based on the id field, and I have used here map field. This is because do not want the address field, but I want the salary amount of that particular employee from the salary master file. So here in this is a one way where we are renaming this emp salary amount field with the emp add. Okay, and then what I am doing is I am calling the we'll come back to this open query file little later. Then I am calling this program rpg program, and then I am closing and deleting the override. So what is happening in this rpg program is, and see here, I have declared that emp mash file which I had opened using open query file, and then I am reading that file till end of the file. I am using the emp address field and emp name field and displaying this. So let us see what happens if I call that this program, our open query file program. um, I'll just quickly check. Okay, so I guess there is some issue. So what it had basically done is that it read that file from the query file, and it had displayed the employee ID name with the salary amount. So the EMP ID was overridden with the salary amount. Now we'll check the next scenario of the open query file, where we are using this open query file to update a particular record. So here what I am doing is I am opening this file pf00 based on a condition where id is 03, and then I am calling an rpg program where I would update a particular record. So if we see that 03 condition is xy, the name is xyz. Okay. And in the rpg program which I am calling, it is updating the name. So I'll call this, and if I check, you can see that the name of the record with id 03 is now updated. So we can use the open query file for performing any operations, either read, write, or update based on the mode. So we have learned like this open query file. Why is open query file used? The steps in open query file, and what is this? Copy from query file. So what this copy from query file is does that if we want the if we want the records that we are fetching using open query file into some other file, we use the copy from query file. So what this will do is that it would copy the records which are fetched using the open query file into some another file where either existing or we can create. So what this is doing that the records which we had open here is copying into another file called as SALDTL. So if I'll SALDTL, so I can see that since I had run that two times, I saw that it is taking the employee ID from employee ID name department from the employee master file, and this employee address field was overridden with the salary field of the salary mash file. So it is copied that particular records into the new file, that is SALDTL. So this is a one way where we can create a permanent object using the open query file also. So that was open copy from query file. So let us quickly recap what we have gone through. We know that now mon message is used for handling error in CL program. We declare a file in CL program using DCLF command, and maximum of one file without OpenID and five files with OpenID can be used to declare in CL program. In order to read a file in the CL program, we use RCVF command. OVRDVF command is used to override certain parameters of a physical file or to overwrite some another file on a base file. EXTMBR is used to override a member in RPG program, and open query file is used to create a temporary access path or get the data from one or more than one files based on certain conditions. These are there are n number of ways in which these two commands can be used. So you all can like try each of these cases, come up with new cases, and if you have any doubt, then you can always reach us. Uh, so I guess that was all from my side. Over to you,
Yeah, okay.
Chandan.
Okay. Thank you, Mitesh. This was really an informative and useful session we had. So, however, we have two questions from KD and Mahima. So, the KD asked like, why do we use OpenID specifically? Like, if what if we don't use OpenIDs for multiple files? Like, if we declared multiple files and if we are not using OpenID, how would it work? So, that is the first question.
Okay, so first of all, if we declare the OpenID and if you do not declare OpenID and declare multiple files, there would be a compilation error. The system doesn't allow to declare multiple files without OpenID. This is because, like we saw, that whenever we declare a file, a CL variable is created based on the fields, name of the fields of the file. So in order to like avoid the conflict in the field names, we use open IDs.
Okay, Mitesh. I think uh, Katie, I think it should be addressed by now. So another question asked by Mahima was like, we are using CPF 4 times 0 for generic errors, right? So
Yes.
like, yeah. So is there any way like we can find out the particular error like using that CPF triple like 4 times 0? Is there any way?
Uh, like, do we want to find a particular message ID for a particular command?
Uh, I
Actually,
think
I'm not
what she meant
clear with the
is, I
question.
think, yeah, I think what she meant is, if we are using CPF 4 times 0, like program level, we are using, right?
Okay.
So that only displays the error message which we want to display, right?
Yes.
That won't show any particular error message that like this error was occurred or something like that. It will only show whichever message we want to display, right?
Yes. Okay. So yes, that is the one drawback of using 0000. That is, we would not be able to find what was the actual error that happened. It is in general would handle all the errors. So if we
Okay,
want
Mitesh.
to handle any specific, we need to mention the specific IDs there.
Yeah. So I
Hence, it
think,
is called a generic one.
yeah. So those all are the questions which we received today. So I think we have no more questions from anybody else. So we can end the session today.
Okay, thanks a lot, people, for being such a great listener. And you can go ahead try this at your end. If you get stuck up of you or you get any new scenarios, then you can anytime reach us either via mail or a ping. Thanks a lot and have a great day. And thanks to you, Chandan too.
Yeah. Thank you, Mitesh.
Yeah.
Thank you, everyone.